Very good morning to all. My name is Rajita, lecturer in ECE, Government Polytechnic, Mamnar. I am dealing with third semester. Subject is network analysis. Now I am going to take a class on the topic to solve the mesh current equations of network by using CRAMERS rule. So before going to this explanation of CRAMERS rule, just I am going to discuss about the last class. So mesh current equations, how to write this mesh current equations. Just I am going to brief the topic. So in the given network, three meshes, we can identify three meshes, that is mesh 1, I1, mesh 2, mesh current is I2, and mesh 3, mesh current is I3. So by identifying these meshes, we are going to write the mesh equations. And these I1 and I2, I3 are the mesh currents, and we are taking the clockwise direction. So by writing the Kirchhoff's voltage law for mesh 1, ZA plus ZB into I1 minus ZB into I2 is equal to E1 minus I2. This is the first mesh 1 equation. Mesh 2 equation is minus ZB I1 plus ZB plus ZC plus ZD I2 minus ZD I3 is equal to E2. This is second mesh equation. And third mesh equation is 0 into I1 minus ZD into I2 plus ZD plus ZE into I3 is equal to minus I3. This is the third mesh equation. So already we discussed in the last class. So these three mesh equations we can put into a matrix form, that is Z into I into V. The three equations we can write in a matrix form. Z matrix into current matrix is equal to the voltage matrix. So from that we have ZA plus ZB minus ZB 0 is the quotients of first equation. Now minus ZB, ZB plus ZC plus ZA minus ZD is the quotients of second mesh equation, and 0 minus ZD, ZD plus ZE is the third quotients of third mesh equation. And I1, I2, I3 is the current matrix. E1 minus E2, E2 and E3 are the voltage matrix. So Z into I is equal to V. So this is the impedance matrix, and this is the current matrix, and this is the voltage matrix. So the above matrix from mesh equations can also be written by simple inspection. So the general form of mesh equations for any three mesh networks is Z11 I1 plus or minus Z12 I2 plus Z13 I3 is equal to V11 plus or minus Z21 I1 plus Z22 I2 plus Z23 I3 is equal to V22, that is second equation. Plus or minus Z31 I1 plus or minus Z32 I2 plus Z33 I3 is equal to V33, that is third mesh equation. So in a matrix form, Z11, Z12, Z13, that is the coefficients of first mesh equation, and coefficients of second mesh equation is Z21, Z22, Z23, and third one Z31, Z32 and Z33 is the completes the Z matrix into I. First current matrix is equal to voltage matrix, where Z11, Z22, Z33 are the self impedance of the each meshes, and Z12, Z21 are the mutual impedance between mesh 1 and mesh 2, and Z13 and Z31 is the mutual impedance between mesh 1 and mesh 3, and the mutual impedance between Z2 and Z23 and Z32 is between mesh 2 and 3 is the so the impedance matrix is Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33. So the left subscript attached to each element indicates the row it occupies, and the right subscript attached to each element indicates the column it occupies. So the diagonal elements Z11, Z22 and Z33 are self-impedances. These three are self-impedances. And Z12, Z21 are the mutual impedance between mesh and mesh 2. And sign negative if current flows in both meshes are in same direction. And sign positive if the current flows in both meshes are in opposite direction. So off diagonal elements continued same Z23, Z32 is the mutual impedance mesh 2 and 3, and the sign negative if current flows in both meshes are in same direction. Vice versa, Z31, Z13 also mutual impedance of mesh 1 and mesh 3, and the same thing. This is the last class what we discussed in the last class. Now, on completion of this period, we would be able to solve the mesh current equations for the given resistive network using CRAMERS rule. Now, I am going to discuss to solve the currents. The last classes, how to identify the mesh currents, how to write the equations, and how the equations we can put into matrix form. Now, after putting into the matrix form, we want to solve the mesh currents. That I am going to discuss now. See, this is the circuit. It is having two meshes. Means we are identifying two mesh currents, that is I1 and I2, and these two currents are in clockwise direction. First mesh is ABEFA. Mesh 2 is BCDEB. These are the two meshes that is identified in this problem. So in mesh 1, current is passing through Z1, and in I1 minus I2 is passing through Z2. See here, in Z1 the current is I1, but in Z2 both the currents are passing and both are opposite direction. So that the current flowing in Z2 is I1 minus I2. So the mesh equation for this first loop is V1 is equal to I1 Z1 plus I1 minus I2 into Z2. That is the first loop equation. In mesh 2, I2 is passing through Z3 and Z4, and I2 minus I1 is passing through Z2. So by applying KVL, we can write that I2 into Z3 plus Z4 plus I2 minus I1 into Z2 is equal to 0. These two equations we can rearrange and we can write it. The first equation is Z1 plus Z2 into I1 minus Z2 I2, and the second equation is minus Z2 I1 plus Z2 plus Z3 plus Z4 into I2. This is the two equations for this circuit. So we can, these two mesh equations we can put into we can arrange into a matrix form. So that is, in the first row, Z1 plus Z2 minus Z2 and minus Z2, Z2 plus Z3 plus Z4. This is the impedance matrix into the current matrix is I1, I2 equal to V1, 0 is the voltage matrix. So these two equations are arranged in a matrix form. And the impedance matrix Z is equal to, it is given, it is Z1 plus Z2 minus Z2 minus Z2, Z2 plus Z3 plus Z4. The current matrix is I1 and I2 and the voltage matrix is V1, 0. So now we can write the mesh equations in a matrix form. Now we want to find out the currents, that is I1 and I2. So for finding the I1 and I2, first we have to find out the determinant of matrix Z. So the determinant of matrix Z is given here. See that? The determinant. For finding this determinant, after finding this determinant, the current we can find out that the delta 1 by delta is the determinant. I2 is equal to delta 2 by delta. What is delta 1 and delta 2? Delta 1 is obtained by replacing the first column with voltage matrix V. So now here, by replacing the voltage matrix, delta 1 is equal to V1 minus Z2, 0, Z2 plus Z3 plus Z4. This is we are getting now. And now similarly delta 2. So the determinant delta 2 obtained by replacing the second column with voltage matrix V. Like that we are replacing that, and delta 2 is equal to Z1 plus Z2 and V1 minus Z2 to 0. So I1 is equal to delta 1 by delta. So what is I1? I1 is equal to V1 by V1 0 minus Z2, Z2 plus Z3 plus Z4 divided by Z1 plus Z2 minus Z2 and Z2 plus Z3 plus Z4. So this is the current. By solving this, we can find out the current. Similarly, I2 is equal to delta 2 by delta, that is Z1 plus Z2, V1 minus Z2, 0 divided by Z1 plus Z2 minus Z2 and minus Z2, Z2 plus Z3 plus Z4. These two are the matrix delta 1, delta 2 by delta 1. So by solving this, we are getting I2. So in this way, we can find out the I1 and I2. So by taking a simple problem, using a mesh current method of analysis, determine the current through 3 ohm resistance in the network shown in figure below. See, this is the figure. In this, we are identified the 3 meshes. The direction is also in clockwise direction. and we have to find out the currents here, I1, I2 and I3. So just we are writing the KVL equation for mesh 1. See here, the current I1 is flowing through 1 and 2, but at the same time through 1 I2 is flowing and through 2 ohms there is I3 is flowing. So from I1 the current is flowing is I1 minus I2, and from 2 ohms it is the current is flowing from I1 minus I3. So that we can write the first equation is 3I1 minus I2 minus 2I3 is equal to 1. This is the first equation. And one is here the voltage 7 volts and 6 volts are out of phase. So 1 into I1 minus I2, 2 into I1 minus I3 is equal to 7 minus 6. So from that we are getting that by solving this we are getting 3I1 minus I2 minus 2I3 is equal to 1. This is the first equation. So the next second mesh, in this there is no voltage source in that, but current 1 into I2 minus I1 plus 2I2 plus 3 I2 minus I3. So by solving this what we are getting, minus I1 plus 6 I2 minus 3 I3 is equal to 0. This is the second mesh equation. And the third mesh equation. In the third mesh equation, the current flowing through 3 ohms is I3 minus I1, I2. And the current flowing through 2 ohms is I3 minus I1. The current flowing 3 is I3 minus I2. And current flowing through 1 ohm is I3. So, the 2 into I3 minus I1 plus 3 into I3 minus I2 plus 1 into I3 is equal to 6 ohms. So, by solving that we can get that minus 2 I1 minus 3 I2 plus 6 I3 is equal to 6. So these are the three mesh equations, and now we have to, for solving this, we have to arrange these three equations in a matrix form. See here, that is the matrix form. The impedance matrix is 3, minus 1, minus 2, and minus 1, 6, minus 3. Third row is minus 2, minus 3, 6 into I1, I2, I3 is equal to 1, 0, 6. So now this is the matrix form. For solving these currents I1 and I2 and I3, we have to use the CRAMERS rule. So by using the CRAMERS rule, I1 is equal to delta 1 by delta. I2 is equal to delta 2 by delta, and I3 is equal to delta 3 by delta. So for all these, for solving these I1 and I2 and I3, we have to find out the determinant of the impedance matrix. So this is the impedance matrix. First of all, we have to find the determinant. That is the current matrix and voltage matrix. So the determinant of matrix Z is equal to 3 minus 1 minus 2 minus 1 6 minus 3 minus 2 minus 3 6. For solving that, how to find out the determinant? So by taking a row 3, first we take the first row, that is 3 into 6 into 6, that is 36, minus of 9. 3 into 36 minus of 9, minus of minus 1 into minus 1 into 6 minus 6. So that becomes 0. So plus minus 2 into minus 1 into minus 3 minus of minus 2 into 6. So by solving this, we are getting that the total determinant value is equal to 39. Now for find out the current I1 is, for current I2 is delta 2 by delta. So delta 2 means we have to replace the voltage matrix by second column. So here I am replace the second column by the voltage matrix, and by solving this we are getting 2 amps, and I3 is equal to 1 by 39. By solving this, the third row column is replaced by the voltage matrix, and delta 3 by delta is equal to 3 amps. And the current through 3 ohm resistor is I3 minus I2, that is 1 amp. So in our problem, the question is the current through 3 ohm resistor. So for current through 3 ohm resistor, we have to find out the I2 and I3. So I3 minus I2 is equal to 1 ampere. Which one is more? So depending upon the direction. If I3 is more, the direction is along the I3. If I2 is more, the direction is opposite, that is along I2. So that is the how we are finding the current in any element. So current is which I3 is more, so that the current in 3 ohm resistor is 1 amp, that is flowing in along the I3. So this is the solution of first problem. Now we are taking another problem. Determine the currents through all branches of given network using mesh current analysis. It's another simple problem. A 6 volts and all the resistors are given, and here mesh 1, mesh 2 and mesh 3 is given, and number of meshes is 3. So assuming mesh currents I1 and I2, I3 with clockwise direction, then the circuit becomes like this. So by applying KVL, the first mesh equation I1 into 1 ohm into I1 minus I2 plus 6 ohms into I1 minus I3 is equal to 6. So from this we can write 7 I1 minus I2 minus 6 I3 is equal to 6. And the second mesh equation is 1 into I2 minus I1 plus 2 I2 plus 3 into I2 minus I3 is equal to 0. Or minus I1 plus 6 I2 minus 3 I3 is equal to 0. And mesh 3, that is 1 into I3 plus 6 I3 minus I1 plus 3 into I3 minus I2 is equal to 0. So from this we are getting minus 6 I1 minus 3 I2 plus 10 I3 is equal to 0. So these are the 3 mesh equations. Now we can arrange into a matrix form. See here the question is solve the all currents in the given circuit. So now we write, already we written a 3 mesh equations, and now we are going to arrange these 3 mesh equations into a single matrix. See, this is the matrix form. 7 minus 1 minus 6, that is the first row, and in second row minus 1 6 minus 3, and minus 6 minus 3 10, that is third row, I1 I2 I3, and 6 0 0. So for finding the currents, we have to replace that. For I1, we have to replace the first column by voltage matrix. For finding I2, the second column is replaced by voltage matrix. And for finding I3, we have to replace the third column by voltage matrix. So before that, what we have to find out? We want to find out the determinant first. That is the impedance matrix. Now we want to find out the determinant. So the I1 is equal to, that first column is replaced by voltage matrix. So we are getting 6. The determinant of 7 minus 1 minus 6 minus 1 6 minus 3 minus 6 minus 3 minus 10 is the impedance matrix. The determinant of impedance matrix is 95. And for I1, it is 6 into 60 minus 9, that is 51. So 6 into 51 is 306 divided by 95. So that is the current I1. Now for finding I2, the second column is replaced by voltage matrix. So here 6 into 10 minus 18, 28 into minus 6, that is 168 by 95 amps. The third one is, third column in impedance matrix is replaced by voltage matrix, and here for finding that 6 into 3 minus plus 36, that is 6 into 39. So we are getting 234 divided by 95. So like this we are solving the I1, I2 and I3 in the given network. So first steps is, first identify. So current through 1 ohm resistor is I1 minus I2, that is 138 by 95. Next, current through 6 ohm resistor is I1 minus I3, that is 72 by 95. So the current through 2 ohm resistor is I2, that is 168 by 95. The current through 1 ohm resistor is 234 by 95. The current through 3 ohm resistor is I3 minus I1, 66 by 95. So these are the currents. After finding this I1 and I2, I3, we have to find out the currents through each element. So for finding the each element, so the current through 1 ohm resistor or 6 ohms resistor, depending upon the circuit, we have to find out after finding I1, I2, I3. So in this way we can find out the currents in each elements or currents in mesh. So first thing is we have to identify the meshes, and then we have to assume that meshes is in clockwise or anti-clockwise. Then we have to write the mesh equations. and whatever the mesh equations that we have to arrange into a matrix form, and from that matrix form we have to solve the currents by using CRAMERS rule. So first we have to identify the impedance matrix, then first find the determinant of the Z matrix. Then for finding I1 is equal to delta 1 by delta, that is by replacing the first column by voltage matrix divided by delta, it will give I1, and replacing the second column by voltage matrix by delta will give the I2. And for finding I3, the Z matrix is third column is replaced by voltage matrix divided by delta will give the I3. And in that way, we are finding the I1, I2, I3. So after finding this I1 and I2, I3, we can find out the current or voltage across the element or current through the element we can find out depending upon the circuit. So now we discussed about CRAMERS rule for solving resistive networks. See here the quiz. The CRAMERS rule is useful when the number of simultaneous equations are less, more than 3, none of the above. So if 2 simultaneous equations are there, means by elimination method we can easily solve that. But more than 2, if it is useful CRAMERS rule. See, more than 3, the CRAMERS rule is useful. So the questions is, take the assignment. For the network shown in figure, obtain the current through 4 ohm resistor using mesh analysis. Here we can identify 3 meshes. And you can assume any direction, that there is no problem in that. So after finding this I1 and I2 and I3, so here the current flowing through 4 ohm resistor is required. So current flowing through this 4 ohms, I1 minus I2 is required. So by writing the 3 equations, by assuming this meshes is in clockwise direction, then the current flowing through 4 ohms is I1 minus I2. So after finding this I1 and I2, will gives the direction. If I1 is more, then the direction is along the current through 4 ohms is along the I1 direction. If I2 is more, the current through 4 ohm resistor is along the I2 direction. So for this, first we have to write the mesh equations, and that has to be put into the matrix, and then we have to find out I1 and I2. This is sufficient for matrix. So then we can find out the I1 minus I2 or I2 minus I1. Thank you.